Hello class. So today what we'd like to look at is the inequality involving fractional expressions. Now, so whenever you look into fractional expressions, what we have to realize is that there are two things. You see, if you're to convert this fractional expression into some sort of an expression, something on top and something on the bottom, of course, is equal to 0. If you convert into this format, then what we end up getting is we get two restrictions. One on top, where the numerator becomes 0, that's where things will become positive or negative, but at the same time the denominator can be also 0 too. In that case, the fraction will be undefined, and that can be another breaker, boundaries for your inequalities. So let's try to get that done together. So first here, what we like to do is we can subtract 2 from both sides. So then we will have x plus 6 over x plus 1, and subtracting 2, and has to be less than 0. Now, to make this one the same denominator, what we like to do is x plus 6 over x plus 1 minus 2 times x plus 1 on top, and also x plus 1 on the bottom. Has to be less than 0. Now let us try to combine them together. And here on the bottom we still have x plus 1, but on top we have x plus 6 on the one side, and then remember, this negative sign will be distributed to all over. So here we get negative 2x and minus 2 has to be less than 0. Now, if you have to combine this one together, then what we end up getting is x plus 1 on the bottom, it doesn't change, and on top we have negative x and plus 4. Now, then here, this is the part where things become nice and interesting. So here from our fraction, what we can do is we can set the bottom equal to 0. That means x will be equal to negative 1. That will be one boundary. And we can set the top equal to 0. That means x will be equal to 4. That will be another boundary. So on a number line, we have two boundaries, negative 1 and then 4, which creating 3 intervals. Now then what we're going to be doing is we're going to plug in a value here, here, or here to see which of them or all of them might satisfy this given condition. So let's try to look at the first section. X has to be less than negative 1, so if you were to let x equals negative 2, for example, then you realize that top is a positive and then bottom is negative, so whole thing becomes negative. And that's what we want because it has to be less than 0. So this one works. How about the second section? We can set x equals 0. How about that? Then our numerator becomes positive, denominator is positive, then it will be positive, and that's not what we want because we are looking for something less than 0. How about on the third side? Third interval here we have, if you let x equals anything greater than 4, what if I have to set it to be 5? Then the numerator becomes negative, while denominator is still positive, so the entire thing becomes negative. That means that also works out. So our answer becomes here, if I were to something greater than 4 and something less than negative 1, that becomes our answer with open circle at either end, at both ends in fact, because we don't have the underline. Right, so we're going to use the same strategy for us to do the second question. That means we're going to subtract 3 from both sides, so that we'll have x plus 12 over x plus 2 minus 3 is greater than or equal to 0. Now likewise, so we're gonna make the common denominator here, x plus 2 and x plus 12, and then minus 3 times, since x plus 2 is the denominator, x plus 2 on top and x plus 2 on the bottom has to be greater than or equal to 0. Once you combine them together, we get x plus 2 is still the denominator. On top we have x plus 12, and on the other side we get negative 3x minus 6. Has to be greater than or equal to 0. Now let us simplify this one further. Then we have x plus 2 on the bottom, and here on the numerator we get negative 2x, and then plus 6. That's what we end up getting. Has to be greater than or equal to 0. Now, then same way as before, let's try to figure out the values of x that will make this one undefined. meaning that's when x equals negative 2, and denominator will be equal to 0. How about for the numerator? That's for x equals 3. So we have two values just like before. Here negative 2 and then 3. So let us designate some values in, and this is what we end up getting. What if you let x equals negative 3? How about that? Then the denominator becomes negative while the numerator becomes positive. So a whole thing becomes negative, but that's not what we want in this case because we are looking for something greater than 0. Here, x equals 0. That means the numerator becomes positive, so is the denominator. So that is positive, and that's exactly what we want. And then the third section here, let's call x equals maybe 4. Then the numerator becomes negative while the denominator is positive, which makes the whole thing negative. And that's not what we want because we're looking for something greater than 0. So therefore our answer becomes the middle section right over here. With the ending points will be closed circles here because of the underline. Alright, great. I'll see you later. Bye-bye.